hi everyone. It's my second time here. I think I've been here maybe 5 years ago before I actually joined Google. So good to be back. I heard a lot of good things about the previous editions of this conference. Okay, so let's start. Forget everything you know about APKs. A lot is changing. And so I'm going to tell you a little bit about the history of the format and how we got where we are today with the new publishing and distribution model that we have on play. So everyone knows the APK format. It's been around for a while, right? But just a little bit of trip down memory lane. So what's in it? It's been like this since the beginning, right? We have resources that make up your app's graphics, all the text strings, everything. There's the manifest. There are any assets that you need for your game. It's all in these files and directories in there. Then there's code, and there's two types. There's DEX code, which is the Java or Kotlin code compiled into DEX bytecode. And then there's native code. So any C, C++ code that you have compiled into shared objects or DLLs, also stored in the APK. And then there's some metadata that no one really cares about in the meta-inf folder. But it is very important, and it has huge implications about on what we can and cannot do with the APK. And like I said, it's been like that almost forever, for 10 years now with Android, and nothing much has changed except small details in how the APK is verified on device. So what's the problem, and why does it need to change? So here is a typical resource table, or more part of it, showing drawable resources for various configurations, for various screen densities, and so on. And the problem is, on a typical device, when you install the APK with all these resources for all screen sizes, you only use a small chunk of it, only the part that corresponds to the device, the screen that your device has. And all the other resources in there in the APK, they just waste space on your device. Even those empty spaces that have no actual resources in them, they still take up valuable disk space on users' devices. They take up download time, megabytes that go through the network to reach the client's devices. And all of that is wasted. So why do we care about that? Well, we found that there is a direct correlation between application size or download size and how many people actually decide to install your app. Or even after they install it, on how many people decide to keep it on their phones. Once they start filling their devices with music, with photos, videos, they can run out of space, and then they will look at the apps they have and think, am I really using this? Do I need this 100 meg app on my device forever? And they will uninstall it. So I think you agree that we should care about it. So what can we do? I told you about the things that are in the APK, the native libraries for all the CPU architectures that are out there on devices, all the resource folders for the various screen configurations and other characteristics of the device. Then there's the resources file, which contains all the strings in all the languages that you have. So obviously, we would love to be able to remove some of those things that the device doesn't need. So if you have an x86 device or an ARM device, you don't need all the shared libraries for other CPU architectures. You don't need all the drawable resources or even language files. So can we do that? Well, the answer is no. And the problem is actually in that meta-inf folder that I told you about before, which contains the signing information for the APK. So there's a file called the manifest.mf that contains a list of all the files in the APK and their hashes, and is cryptographically signed so that no one can change it, no one can tamper with it, which means you cannot remove any files from the APKs, and you cannot change their content, which is great because then once a user installs an update to your app, they can be sure that no one has changed the APK, that there are no Trojans, viruses, or anything like that, because it's signed with your key that you possess, and no one else can sign that APK for you. So there were solutions over the years to the problem of these fat, bloated APKs containing all the resources possible. And multi-apk is one of them. It existed for a long time, as Play Store supported it for years. And the solution is to basically build multiple APKs that only contain the resources for a certain device configuration. So take screen densities, for example. Of course, bitmaps are usually the biggest things, the biggest resources in the APK. So if we can split them into multiple APKs containing only the resources for the screen size you have, that's great. Now the users don't have to download all that additional crap. The problem is, there's really many screen configurations that you have to target. And I listed only 4. There's probably like 6 or 7 or 8. And then what happens if you also have native libraries? Suddenly, instead of these 4 or 5 APKs, you have to create more because you have to split on the ABI, on the CPU architecture. And suddenly you find yourself managing 8 to 16 APKs on the Play Store. And then you decide, oh, let me do a major API bump, but I still want to keep the old version of the app for the previous users and now serve the new one to the new users. And suddenly it explodes. You have 30, 60 APKs to upload to the Play Store. And then there are different configurations that you can split on if you're, for example, if you're making a game and you need to split on texture format. But let's not get into that. Let's focus on the main characteristics, such as density and ABI. So fortunately, Android Studio, for a long time now, provided this option to provide the splits configuration directive in Gradle. And it does the ABI and density splitting for you. So it creates all these multiple APKs. You don't have to do much. It kind of just works. But there's one big hurdle still. You still have to manage version codes by hand. So all these APK that you make, they have to have different version codes because you can't upload 2 files with the same version code to play. And so we had this huge guide on DAC on how to version your apps by combining and multiplying various multipliers into your final version number. And again, let's not get into that. Fortunately, we will be able to forget that soon because it's really not great. And there's one more thing. Why I put splits in quotes here? Because the configuration directive in the Gradle DSL is called splits. Multi-APKs became known among developers as split APKs, which I came here to tell you is completely wrong. And I'm going to explain in a little bit why. So let's stick with the name multi-APKs for the old way of doing things, okay? So why is it wrong? Actually, there was a hidden directive that we never talked about because it wasn't supported, called generate pure splits. It was introduced at the same time as the regular splits to support something that Android 5.0 Lollipop introduced, which was the possibility of installing multiple APKs as one application package. So you could push a few smaller APKs, and they would sit on the device, but they would be run as a single application. And these were split APKs. So you can see not only they supported splitting on densities and ABIs, but also languages. But that was not supported by Play. That's why we actually never talked about it. So why was it not supported by Play? Well, it is a difficult problem. I mean, imagine you split your APK into multiple APKs containing separate languages. What happens if a user has their phone, I don't know, in English, installs your app, and then they switch it to another language? Like, how would that work? It actually takes a lot of infrastructure work and on-device infrastructure to support that. And to be fair, sometime for the past 3 years since the splits were introduced, the Play folks were very busy. So small intermission, if you haven't used any of those things that they introduced, like alpha and beta tracks, stage rollouts, store listing experiments, app campaigns, smaller downloads, smaller updates, pre-launch report, Android Vitals, extremely useful things, and many more, please check those out. However, that's not something I came here to talk about. The thing is, it took time. And meanwhile, in the previous years, app size has really become a problem. So if you remember correctly, previously the size limit on the Play Store was 50 megabytes. However, we found that some larger apps were quickly approaching it, and they wanted to add more features. So the short-term solution to that was simply raising the limit to 100 megs. But we couldn't do it, always. We could be raising it to 200, 300, but that's not the point. And also, developers actually started to be interested in reducing their app size. So we got the APK analyzer in Studio. We got articles, talks, people actually talking about how to reduce their APKs. Not just us, but also external developers at conferences and so on. And also, we found that apps were experimenting with dynamic code loading. So imagine you have an app that's approaching this 100 meg limit, and you still want to add one great feature. So they thought, OK, well, we will not put it in the APK. We will just put it on our servers and then download the code dynamically when the user runs it. The problem is, we never offered a supported solution for this. And when developers rolled their own, we found that there were terrible, terrible security issues because it's not easy. It's actually not easy. Dynamic code loading is hard. You have to think about the whole journey of the code that you download, from storing it securely at your server so that no one actually changes what's hosted there, to security in transit. And believe me, we saw apps that were downloading code over HTTP so that literally anyone could just switch the file and install something else on the device. Then there's signing and verification. So I told you about APK signing. That's built into the system. That's tested, used by every app out there. If you do your own dynamic code loading, you will have to roll your own crypto, which you should never actually do. And then there's more questions like, how do I store it on devices? If I put it on an SD card, can any other app replace that code? So do I need to re-verify it every time I run? So I think you agree that dynamic code loading is not something an average developer would just want to code in 2 weeks. Meanwhile, as I said, security and privacy of the users was really important to us. And so in Android 7, we introduced an even newer, even more secure signing scheme, App Signature Scheme v2, which not only signs and verifies the contents of the files inside the APKs, but it actually verifies all the bytes in the APK so that no one can tamper even with the binary contents of the file. It required a new tool. It's built into our build chain, so you don't have to worry about it. If you remember to not disable it, you will get this by default. And there were actually more benefits. And not only was this stricter, but installation time was way faster. So instead of having to verify all the files in the APK and uncompress them for that, which can take even seconds, with the new signing scheme, we found that it can be faster by an order of magnitude. So it only took a couple hundred milliseconds to install a file on Nougat and above. So people started thinking, now that we have this, and also now that we're trying to make apps really small, what else can we do about it? And so in 2017, we announced something called Instant Apps. Now it's called Google Play Instant. It's basically the same thing. And these are native Android apps that are available for users without explicit installation. So without going to the Play Store and deciding, I want to install this app, I want to keep it on my phone forever. So it's a completely new discovery model for apps. And it's great. It requires some changes. It's not easy to actually add an instant app if your app wasn't modern enough. And that's because instant app required, for example, runtime permissions. They also have some API restrictions. And the difficult part for developers was that instant apps required implementing app links. So that's a connection that you make between your server, your URL, or rather a domain that you control, and your app. And then they had to be 4 megabytes or less for any given URL that launches your app. Okay, so now a very quick run-through of how an instant app is structured and how it works. So most apps were a monolithic APK. As we know, you install a single APK, the app is there, the user can use it. However, in your projects, in your local Android Studio project, you probably modularize your app to have better code structure, to be able to compile it faster, and so on. And so usually, you probably have some kind of common or base module where you have, let's say, your databases or your networking code. And then you have, let's say, UI modules that use this shared code. So if you can identify a feature of your app, such as a screen or a functionality that's self-contained, that offers a user value, and if that feature can be represented as an entry point of your app that's available under a certain URL, what if you could take those two parts of your app and package them as small self-contained APKs, a base APK and a feature APK? And of course, you can have many more features in your app. If any of these combinations of features and base modules are under 4 megs, you basically can have an instant app. And the users can simply click on the URL, and then Google Play will take care of downloading these small feature APKs, installing them quickly in the background, and running the full native experience of your app. Okay, but that's instant apps. That's also not the topic of this presentation. However, I talked about split APKs before, and it's really a problem to have an app that's less than 4 megabytes, even if you just pick one screen of your app that's supposed to run. And so these base APKs and feature APKs, even if you just carve out a section of your app, they can still be pretty big. So what we did in the build system we actually created all these configuration split APKs for you, taking only the shared code and resources, putting them in those base APKs, and then splitting out all the screen density resources, all the native libraries, into separate small split APKs. Oh, and languages also. And basically, whenever a user installed it, the system dynamically chooses which ones should be downloaded from Play and installed. And that's the first time actually split APKs have been used. So here we have a new bundle format. Well, this is the legacy one that was introduced with Instant Apps. All these split APKs were created at build time. So during your build, we create all the possible configurations, package them up in a zip file, and upload them to the server. So that's great. That worked for Instant Apps. However, we would love to have that for full installed apps as well, right? So what happened next? Also in 2017, we introduced something completely new on the Play Store, and that's app signing by Google Play. So as I told you before, previously, you developers had your release key that was used to sign your APKs so that no one else could tamper with them. And that was great. You had full control, and you can still have it. However, it was not ideal because you uploaded APKs to Play that were already signed. We could do nothing to optimize them. Play could literally not change a single byte in your file. Also, there were more problems. If you ever lose your key, we cannot help you. Like, Google cannot let you update your app if you lose your key because it's just not possible. Cryptography just prevents that. And so, with app signing, you are offered the opportunity to upload your release key to Play so that you can never lose it, so that we can apply more optimizations to your APKs. And this process is, by the way, totally secure. You get back an upload key that you use to sign your APKs to upload them to Play. We can then re-sign them with your release key, and you can be sure that you never lose it. So that's great. And all of this experience with split APKs, instant apps, app signing, finally leads to the new publishing format, which you probably heard about at I/O this year. And it's the Android App Bundle. So it's the first big change in 10 years in how you build and package your apps and upload them to Play. So we call it a publishing format or a publishing artifact. That's because this is something you upload to Play. However, what gets finally to clients' devices are still APKs. So Play takes care of this, transforming this into APKs. So why is this format different? I would say it's something like an intermediate format between your Android Studio project and the final APK. It preserves some more information about modules that have been present in your Android Studio project. It contains some more metadata about the files that are inside and which devices they should target. And the new format actually works closely with something we call Google Play Dynamic Delivery. So it's a function of Play that actually takes those AAB files, and creates and delivers those smaller split APKs optimized for client devices, containing only the resources, only the native libraries they need. So this works for all Android devices. Of course, we only have the biggest benefit on L and above, where splits are actually supported. But don't worry, for pre-L devices, we just fuse everything together, create this big APK, and deliver it to the device. So that's great. You don't have to worry about it. And currently, what's supported is splitting by ABI, density, and language. So that's even better that you could do with multi-apk, because you get the benefit of language splitting as well. Moreover, you never have to worry about version codes again, because you only upload one artifact. You don't have to manage all these different version codes for APKs anymore. So how does an app bundle look like? It's also a zip file, similar to an APK. However, the structure is a little bit different. Like I said, it preserves more information about the modules in your project. So we have folders for every module. Then we have these PB files, which are protobufs containing the metadata that I told you about. So there's some config about the bundle config file contains some information about which tools and built your AAB and some more configuration data. Then there's asset targeting for assets, resources, and native files so that Play can know which devices they target. And then there are these dynamic features that I'll talk about a little bit later on. So how do you actually get there? How do you transform your project from a regular APK to an AAB? That's the best part. The only thing you have to do instead of building an APK with something like assemble release, you simply bundle release, and that's it. You don't have to you don't have to change a single line in your code. You don't have to use some APIs or anything. You simply build a bundle, upload it to Play, if you enable play signing. That's one important part. And that's it. You get size savings of between 20 and 60%, depending on how many native libraries, how many languages and resources you have. And so everyone should do it. There's no reason to not use it. It's totally in production. Thousands and thousands of apps have switched to that, and it's great. If you're worried about, for example, not having all languages in the APK available at installation time, you can disable a certain split. So instead of using the splits directive as previously, there's a new one in Gradle called bundle, and you can disable splits if you wish. However, for most apps, there's no reason to do that, and you should just leave it on default. Okay, so what about this other part? So we talked about size savings. Everyone should do it. It just works. However, actually, app bundles unlocks a whole new world of optimization that you can do to your apps. And these are dynamic features. So what are dynamic features? They are feature APKs or split APKs that are installed on demand as the user requests the functionality from your app. So it's on one hand, it's a new Gradle plugin for building your modules. Instead of having, let's say, a library that gets fused into your big APK, you now can build a dynamic feature that's a completely separate, self-contained part of your app. And that's something we've never had before. Remember when I talked about dynamic code loading? Imagine you have a big app where 95% of users only use the main functionality. Let's say it's, I don't know, a ride-hailing app, and most of the users just call a cab, right? And they are not drivers. So imagine, why would you bundle all the code for drivers in that app as well when no one is using it? Why not carve it out and move it to a separate dynamic feature that will be loaded on demand only when a driver actually requests it? So that's just one idea that could work for many other different types of apps. So yeah, it's a new type of module that you need to have in your project. There are some manifest entries that can specify if the module is to be loaded on demand or loaded automatically when the user installs the app. And what about these users that are pre-L that can't actually install Split APKs? Well, if you include the fusing true parameter, then that module will be installed for them at install time as well. Okay, so how do you actually load code dynamically? Like, how does it happen? So there is a new SDK, a new library called PlayCore. It's available on our Maven, and you will basically interact with two parts of it. So I'm not going to go in depth into how the API works. We have pretty good manuals for that. However, just to give you an idea how it works, with Split Install Manager is used to actually request installation of these dynamic features in runtime. So whenever a user actually accesses that part of your app that's not yet installed on the device, you invoke this Split Install Manager, tell it, the user is trying to access this APK, please install it. You get a request back, you get callbacks. You can show some fancy loading UI to the user. It should take a few moments, and then the user can access the code loaded in the dynamic feature. However, there is a small problem. Unfortunately, on legacy versions of Android from 5.0 that supported Split APKs, there have been some problems with actually installing them at runtime, so that only when the app was restarted could the app fully access resources and code that were installed with a Split APK. That's why we also created something called Split Compact. It's also part of the PlayCore SDK. And if you install it, if you add it to your application's attached base context, this basically lets you emulate runtime installation of these APKs so that you don't have to tell the user, oh, now please restart the app and you will be able to access this functionality. Instead of that, you can actually access whatever was contained in the APKs directly at runtime. So there's a few caveats, unfortunately. Once you request an installation of a new module and you want to access the newly installed assets, you have to remember to refresh your context. And so you do something like that. You create a new package context with your package name. You create an asset manager from that. And from now on, you can access resources that were contained in that new APK. For native libraries, if the Split APKs contains native libraries, you just have to remember to load the files. Instead of doing system load library, you call split install helper load library. And it makes sure that it also checks these new APKs for your native libraries as well. Now, for accessing newly installed DEX code, that's something more difficult. Because, well, you have to use reflection, unfortunately, because of how the project is structured. And when thinking about it, I came up with 3 pieces of advice that I can give you. So the main problem is that the dynamic feature, the Split APK that you will be installing at runtime, it depends on your app and not the other way around. That's why from the main app, you don't have access to classes from it during compilation. So one solution is, if you can extract that functionality that you need into a pure Java module and have your dynamic feature depend on that, you could theoretically have the app also depended with a compile-only type of dependency. That means that you don't have to use any reflection to access the classes that are contained in the Java library. However, probably for most apps, that will not be the case, because a Java library cannot use Android SDK interfaces, it cannot use Android resources, and so on and so on. Okay, so what can we do? Another solution is, well, simply create an interface in your main app that you will then implement in the dynamic feature. And, well, now you only have to use reflection once. You have to somehow create an instance of that class that you need that implements the interface, probably using reflection, and then simply cast it as your interface, and you no longer need reflection. You just use the myInterface methods. However, probably for most apps, this will look something more like this. Now, remember when I talked about instant apps, where you actually take part of your app, like a screen or a series of screens, and refactor it out to a separate APK. If you have that, if your dynamic feature is actually a self-contained activity or fragment that can simply be invoked from your main application code, and then like the whole program control moves to that, you can actually just call it by intent. The main difference is that usually when you have an activity, you would probably simply use the class name, the class here, the actual class object of that activity. Because like I said, you don't have access to these classes in compilation time, you simply have to use the set class name with literal strings here. And now once you've launched that feature activity from your main activity, you don't have to worry about reflection or anything. Now program control is here, this activity is running, you can access anything that's in your installed APK. Okay, great. If you want to look at how this looks, please check out the sample for dynamic features. It contains code showing you how to load native libraries, resources, and DEX code. What else? There is a new tool that you can get on GitHub for working with Android app bundles. It's called Bundle Tool, and it lets you locally on your computer simulate how Play Store would build these Split APKs for various devices. What you can do is you can even connect your phone to your development machine and tell Bundle Tool, generate the APKs that would be installed by Play on this device from my bundle. So it's great for local testing. Unfortunately, there's one problem. If you use dynamic features, there's no way to test it locally. The Play core library works together with Play, and it will not let you install dynamic features, I don't know, from your local dev machine. That's why we introduced a new internal test track on Google Play. So it's, in addition to the alpha and beta channels, there's a new test track just for your developers. It can support up to 100 testers. And what's the difference from alpha and beta? It has instantaneous rollouts. So if you're developing a dynamic feature and you want to test it locally or on the emulator on your device, you simply upload a bundle, and within a few seconds, it's available for your device to install. So that's great. I really encourage you to try it. And then I talked about Google Play Instant for a bit and how it's really difficult to structure your project so that you build all these APKs and then you upload the different instant app bundle. Well, there have been some changes in 2018, and we are making it easier for you to actually create an instant app in addition to your installed app. So one of the changes we're making is that we're experimenting with a 10 megabyte limit. It's currently in beta, only under a whitelist, but you can apply for it. So that you don't have to make your apps as small as 4 megabytes. 10 megabytes might be a more reasonable limit. We'll see how it works out. Second, we no longer require URLs and asset links for your instant apps. So you no longer have to maintain a website that has a verified connection with your app. You can simply specify a default entry point for your instant app, and then you can link to it from ads, and more importantly, straight from Play. So when users go on your app listing, other than the install button, they also see try now. And this launches them into the instant app experience. Okay, so what about building them then? Well, we just introduced instant-enabled app bundles. So we are leaving this legacy instant app format behind, and now we want to help you have a single unified project in Android Studio that will let you build both your installed and instant app experience. So this is how it previously looked. If you ever made an instant app, you know you had to have this weird structure where you refactor all your code into this base feature, and then have two, I would say, dummy modules that don't contain any code, anything. They simply exist just to build the installed application and the instant app version of your app. Now that was pretty weird. So we're actually getting rid of the instant app plugin, so you no longer need to use it. And then instead of having this feature module here, we simply use the application. So it starts looking just like your regular old Android Studio project. Probably most of your apps are structured like this. Oh, and this feature plugin that was used just for building instant apps, we are now switching to dynamic feature. And so you have a typical Android application that can depend on any number of Android libraries and dynamic features if you choose so, and that's great. The problem is that currently on Play, even though we support uploading bundles that are instant enabled, you still need to upload two. You need to upload a bundle that's an instant app, and that's an installed app. And for that, you need two product variants with a slightly different setting in the Android manifest. We have a new guide on DAC, by the way, for that. There's probably no time for me right now to go through it. However, that's great. Now you have a unified product structure, just two product flavors, slightly inconvenient, uploading to two bundles. What we are aiming for pretty soon, and by the way, this is something you can use on Play right now, but coming soon, we really want to enable you to simply build one bundle, and then if any entry point in your app is less than 4 megs or less than 10 megs, if the limit is lifted, you will get an instant app enabled experience. That would be awesome. All right, so if you're interested in app bundles, and like I said, everyone should be switching right now just for the size savings, go under this link. It will take you to the Developer Android comp site with guides on how to structure your project, to support app bundles, to support dynamic features, and try it out. Give it a try. You can use the alpha and beta tracks if you're worried that something will break. And thank you.